In this video, we are going to understand the mean value theorem. We're going to read through it and we're going to understand it geometrically, in other words, graphically. So if we take Rolle's theorem and we just turn it on its side, you'll get the mean value theorem. This is what the mean value theorem says. If a function satisfies these two hypotheses, it's continuous on the closed interval, a less than or equal to x less than or equal to b, and differentiable on the open interval, a less than x less than b, then there's got to exist at least one x value, x equals c, in that open interval, such that the derivative there is equal to f of b minus f of a all over b minus a. Equivalently, if I multiply both sides by b minus a, I get this statement. This is an equal sign right here. When I printed to PDF, that didn't come through. So on your end, it looks like a subtraction sign. It's an equal sign. Let's understand this graphically, geometrically. F prime of c is the slope of the tangent line. To what curve? To y equals f of x. At what point? At c, at x equals c. At c, comma, go find y on f, right? So here we have a, b. Say the function sends a up to this particular y value, f of a, and b up to this y value, f of b. And my function, we have to connect those 2 points nice and smooth and continuously. Well, maybe it looks like that, just as an example. F prime of c is the slope of that line. Okay. F of b minus f of a all over b minus a is that average rate of change. It's the slope of the secant line, containing the points a, f of a, and I'm even going to do them in black to emphasize we're on f, and b, f of b. Okay, we'll draw a picture. Okay, so I've just got this picture over here, and I'm going to go ahead and draw in my secant line. So, geometrically, when we say f prime of c is equal to this average rate of change, f of b minus f of a all over b minus a, what we're actually saying is that there is a c that lives strictly between a and b, such that the slope of this tangent line is equal to the slope of the secant line. These lines are parallel. These lines are parallel. That's not spelled right. I'm missing a vowel. Parallel. Okay? And so you can see how we've turned Rolle's theorem on its side. Rolle's theorem is just a special case of mean value theorem where I require f of a and f of b to be the same. So if I made f of b the same as f of a, then we're down here where we've got horizontal lines, right? We have pictures like this. Okay, let's look at this Desmos graphic, and then that'll conclude our video on the mean value theorem. Okay, all of these animations that I've made are entirely programmable, so you could come along and just change this rule F, and you could change these endpoints A and B, and you would have a picture for a new situation. So all mean value theorem is saying is if we have a function that's nice and smooth and continuous on the domain A to B, including those endpoints, then there's gonna be at least one value, there she is, x equals c, such that the slope of the tangent line, green there, is equal to the slope of the secant line, that blue secant line right there. And that's it.